Okay, this is the 2014 External Exam Question 1. Now you can pause and read the question if you need to. What proportion of people in this trial had no fractures? So we've got 2127 altogether, and the number that had no fractures would be 1887, and you need to check that on your calculator to see if that fraction will simplify, or you can write it as a decimal, 0.88716. Part 2, what proportion of people in this trial? So 2127, it's out of all of them. We're given A and had no fractures. A and no fractures, 973. Once again, see if that simplifies, or write it as a decimal. What percentage? Now this one says what percentage, so I notice that I need to make sure that my answer is a percentage. Who did not have a fracture were given the placebo. So what percentage of people in this trial who didn't have a fracture? So that's these people in this column. So we're looking at the 1,887 people that had no fraction. We want to know what percentage of them were given the placebo. So I can see it's 914. We wanted a percentage, so we need to times by 100. And that gives me 48.44%. That could be rounded, I'm not sure. Right, claim is made that taking A halves the risk of having a bone fracture for people. Can this claim be justified statistically? So what we want to compare is the probability of having a bone fracture if you take supplement A, and we want to compare that with the probability of getting a bone fracture if you're not given A, which would be the group with the placebo. So that's what we want to compare. Right, using the table, so this is all the people given A, and if you have a look back there you'll find there were 1065 given A, and the number of those that had a bone fracture were 92. So if we just go back and check, number of people given A, 1065, and 92 of those had a bone fracture, right? And the second probability we want is those given the placebo, which is 1062 in the denominator. The probability of them having a bone fracture would be 148. Right, so this one was 148 out of 1062. I'm going to divide those and compare them. This is 0.08638, 0.1393, and when you do that division you get 0.62. Now we're told that taking A should halve the risk of having a bone fracture, but actually here's my risk of having a bone fracture without it, and if I halve that I get 0.06. That's not what we want to do. This here should be 0.5, so we want this risk to be half, and I can see that it's more than that. It's 62% of the one at the bottom, so this is not close to 0.5. So I would not accept the claim. That taking A halves the risk of a bone fracture. Now it does say in the assessment schedule that if you argued that 0.62 was reasonably close to 0.5 and therefore you did agree with it, then that would be okay as well. It's about justifying and comparing the 0.62 with the 0.5. Right, part D. Taking supplement A slightly reduces the risk of having at least one fracture for people aged between that. Prevents 1 person in 20. So 1 in 20 is 0.05. So suppose 100 people were to take supplement A, then the number having at least one bone fracture, we know that out of the 1065 people that did take A, 92 had a bone fracture. So that's the fraction that do, and we're assuming there's 100 people, then we could expect approximately 8.6 people to suffer a bone fracture. Suppose, let's compare that with 100 people who don't take the supplement, in this case the placebo, and the probability of them having a bone fracture was that fraction there. We just did that above. So out of 100 people, therefore the number having a bone fracture would be approximately 13.9. We could round that to 14, and this one we could round to 9. So by taking the supplement, we've actually saved 5 people out of the 100 from having a bone fracture. So 5 people, which is the 14 minus 9, are saved from a bone fracture if they took supplement A. And of course 5 out of 100 is the same as 1 out of 20, which is 0.05. So this time we would agree with Nairi's claim.